Hi Mohsen, thank you for your email with that lovely picture of all that lun. I would like to go through that question with you now, if that's okay. So, up on the board, I've got the definite integral that you wanted to evaluate. I'm going to go through that step by step. First things first, just like you did, we need to substitute the upper bound into this expression. And I believe that's the substitution that you had for the upper bound as well. Taking the 2 in there, 2 times 2 plus 1 is 5, 2 plus 1 is 3, 2 plus 3 is 5. And just like you did, I'm going to go on and substitute in the lower bound of 0 as well. But what you did is you divided. And with evaluating definite integrals, we always subtract. So, the substitution for the lower bound, 2 ln 1 minus 3 ln 1 plus ln 3. And that line of working is equal to the one above, and I like to show that. What we're going to do now is we're going to try and evaluate this, and this relates to your point in the second email about simplifying down the terms. So the first thing I want to do is I've got these brackets on, I want to get rid of those. These first set of brackets aren't really doing anything apart from just making my substitution clear and sort of showing what I'm doing, so I can remove those without any processing. Just the same as the line above. But these brackets are doing something. They're telling me that I'm subtracting all these things. So I'm subtracting 2 ln 1, and I'm subtracting minus, so I'm adding 3 ln 1, and I'm subtracting ln 3. The signs of everything, that's positive, so the sign's now negative, negative, sign's now positive, positive, sign's now negative, because I've multiplied through by minus 1. Now this next step, collecting the like terms up, I could look at it in two ways. The simple way is, that's a ln 5 and that's a ln 5. I've got 2 of them here and 1 of them there, so I have 3 of them. There's 3 ln 5. And in practice, that's actually what I did. But there is an understanding that lies underneath that, which is useful for your exam, so I'm going to go into it. I'm going to use a couple of different rules. The first rule is that if I've got a log b, that's the same as log b to the power a. I can take a coefficient and bring it up as a power. So applying that rule to these situations here, which I'm going to do now, gives me this. It's worth noting that 1 squared is just 1 and 1 cubed equally is just 1. I'm going to come on to these more later. But for the moment, what I'm going to do is I'm going to start gathering these in the order that I want them. I want the ln 5s first. And then I'll have the lns with bases of 3. Well, not the ln itself as the base of ln is obviously e, but within, inside the brackets, the base is 3, the power is also 3, but not for that one. I'm going to just put 1 there because why not? Okay. Now, there's a couple of things I'm going to do. This bit here, to make my life easier, I'm going to take out a common factor of minus 1, turn to a bracket, and that's going to give me ln 3 cubed plus ln 3. There. I took minus 1 out front, so that's no longer negative, that's accounted for here and there as well, making both of these positive. I'm going to copy the rest of it down just for completeness sake, because I'm a maths teacher, we like to be accurate, I guess. And actually at this point I'm going to save myself some trouble, because I've been writing out those ln 1s at the end, and I could leave the explanation for that for some time, or I could save myself some work. Because if you use your calculator, you'll see that ln of 1 is 0. That's because any logarithm is asking the question, what power of this base gives me this number? What power of e gives me the answer of 1? Well, e to the power of 0 gives me 1, because x to the 0 always equals 1. So that's equal to 1, and that's equal to 1. Sorry, equal to 0, and that's equal to 0, so there's nothing there. So in fact, I can ignore those already. 0, 0, gone. These two bits here, though, I'm going to use an additional rule. Log of a plus log of b is equal to the log of a times b. Using that rule, and I guess a bit of index laws, combines these two down to that. 5 squared times by another 5 is 5 cubed. The contents of the brackets here, now I've got that negative outside, in the same way, 3 to the power 3 times by 3 is equal to 3 to the power 4. Gives me that. And since they've been combined into one thing, I don't need a set of brackets around them to show that that operation has to be done first, because there's no operation that's all been done. And all of these are still equal. Now earlier I showed you the rule that I can bring a coefficient up as a power. Well, I can bring a power down as a coefficient in the same way, meaning that that 3 there, that can drop down in front, and that 4 there, that can drop down in front, giving us the answer that we were after.